Hi, this is Len. I'm taping a roasting session with my 2-pound capacity, upgradable to 4-pound capacity coffee roaster. I recently converted this roaster from 220 volt AC electrical heating element to propane gas. I'm going to be hooking up the propane cylinder here to the roaster. I'm going to go over a couple things about the roaster. It's a negative air pressure type design where it uses a vacuum motor right there. There it is, right there. These are the motors that typically inflate hospital beds, believe it or not, and they have a variable rate controller built into them. You can usually pick them up used on eBay for around $80, and that's what I did a few years ago. This knob right here is the one that adjusts the vacuum. So it creates a negative air pressure in the roasting chamber, which is this chamber right here. And taking the lid off for you so you can see inside of it a little bit. I'm doing this all myself here. I'm not that good of a video recorder. Creates a negative air pressure in there which allows the beans to spout. And that way that combined with the heat that's being produced by the gas jets here. There's one on this side right here, and this right here, this thing, that's a gas igniter, electric gas dryer igniter. This right here is the propane gas jet. So it fires up, air is sucked into it instead of blown into it. You can see the holes in the bottom maybe. A little difficult with this flashlight thing I have here on my head. There we go. You can see holes in the bottom. That's where the heat goes into the roaster. So it goes into the roaster through the bottom. There's one on the other side too. There's a gas jet on the other side too. Spring off the top that just holds the lid in place when it's in storage. Get that out of there. Yeah, you can see it's kind of like a negative. Anyways, there's the other one. That's weird looking. Anyways, that's stainless steel. It gets so hot, it'll melt aluminum or make it not good for sure. The roasting chamber is 100% stainless steel. It's basically a stainless steel bowl modified with all kinds of stuff I did to it. There's another bowl inside. So that's what the roaster looks like. Not set up yet for roasting, and I'm going to take the front cover off right now. So I'll give me a second. I'm going to take that front cover off to show you some of the end. Okay, I took the screws off the front cover. Now you'll see these two fans. These two fans blow in. This is a cooling mechanism for the what you'll see is a tube inside. Right back there, you see a tube that goes straight across. Okay, here's the roasting chamber. There's a little very high temperature silicone type reinforced tube that goes into the roaster here inside this roaster. And that back tube is an aluminum. I think it was aluminum. Might be steel. Actually, it is steel. Tube. That tube goes right into the vacuum unit, and from the vacuum unit you see this high temperature hose again that actually goes right out the window. I just put it up there, a little hole in our window thing there. Dryer goes out it too. So that's the roasting smoke that goes out of that small tube. Anyways, these fans blow across that steel tube and back and cool off the high temperature exhaust from the roasting before it enters the vacuum motor. I've had the vacuum motor for a few years now. It's running well still. So it wants, you should cool it down before it gets in there. These are all the electronics. Here's the PID for my profiles. There's an SSR that comes off the PID. The SSR then goes into believe it or not, goes into another relay. And that relay goes up into a AC to DC converter, which goes down into a special kind of high pressure propane solenoid, flow solenoid, on off shut off valve, especially made for propane. I would imagine that it has to do with not creating sparks or something like that. So the propane goes from the tank right here, goes inside this thing here, inside the roaster, goes into that solenoid valve, then from the solenoid valve it goes out to the propane jets. I extended the tubes out because of course they get hot right there. By the time it gets into this area here, it's cooled down enough to the point where I can put it into a thick silicone hose where you can't even tell that the copper tubing really is even hardly even warm at that point. I had to do that because prior to that I didn't have that long extension, and people on I think it was Alan on Home Roasters advised me to make something like that because the silicone was actually melting at that point right there, and it doesn't now. So thank you, Alan. When the PID is in operation, which is turned off now of course, it'll say, oh, the roaster needs some heat. So I'm going to pop on that solenoid to let some propane gas go in, and these at that point these electric dryer igniters are red hot, so it fires up the propane gas right there, and all that heat is sucked in through the roaster, through the beans roasting. And then it gets up to the profile point, and the PID here says, nope, you don't need any more heat. So it shuts off the solenoid, turns off the gas. The igniters stay on throughout the whole roasting process. The beans continuously do their spout and their roasting, and then it calls for heat again, so the thing turns the gas on again. It's a pretty neat little system I developed here a few years ago. Again, it's upgradable to 4 pounds capacity. Right now, as you see it, it's at the 2 pound capacity. The 4 pound capacity, I have an extension that goes on this thing. It brings it right up to about here, and it works pretty decent, but I don't need it for myself. This roasting I do is all for myself. So a little bit more about this roaster. At the very end of the roasting process, I have a type of water mist that rapidly cools down the bean mass, and that's what this bottle here is. It's full of filtered water. So at the end of the roasting process, when I've finally completed my roast, I want to cool it down real fast. I just, the spouting action is still going. It's still in this fluid bed action, and I just press this periodically. It shoots a stream of water into the chamber, which quickly vaporizes and cools down the bean mass, cools down the whole thing, and it drops the temperature pretty rapidly. And I keep the process up like that periodically until it goes down to about 320 degrees, and then I just let it go. It goes from the roasting on over 400 all the way down to ambient temperature very fast. And that's that. I'm going to stop for a second again to put this together, and then we'll get going on our roasting. Okay, we're back here now. I put the cover back on, and I thought I'd show you a little bit more of the interior of this roasting chamber. You see the little center tube that comes up. That helps a lot in the spouting of the spouting process for this roaster. And right here is the top cover that I put on. You see a little tinge of coffee oils around it inside. There's a, again, there's a water bottle for the mister. There's a little where the water comes in at the very end when I cool it down. So basically inside of it has it's actually a 2-bowl thing, a 2-bowl. You have the interior bowl with a perforated 3/16 inch perforated cylinder that I built up over it. Then you have the outer bowl, which is stainless. This is all stainless, tube stainless. Right here we have the de-chaffer feature that I did. You see this tube right here that goes in. That tube. The air goes in through there from the vacuum. Alright, the tube right here, air comes out of that from the bottom, from the burners that connect in through this bottom chamber here. They're both connected. What I do with this de-chaffer ring, I just put it right inside here like this. Fit it right in, just like that. What happens is that when the top lid is on, the beans will be spouting up through this thing, and they won't be able to escape the inner cylinder because of the lid, but the air will escape, and so will the chaff because of the perforations here, as you can see. Alright, so the beans always stay in the center here, but the chaff comes out again through the perforations, but gets trapped at the much finer perforations of the de-chaffer ring. Doesn't clog up ever because of the very wide circumference and surface area of that de-chaffer ring. So there's no restriction of airflow. I do clean it out each time I do a roast, but it's really not necessary. That's how that all works. Now it runs on 110 volts AC, which is nice. I have it again. Let the exhaust goes right out the window right there. Now I'm pre-measured out almost 2 pounds. 1 pound 15 ounces of beans. I'm going to be roasting these to a full city plus today, 454 degree bean mass temperature. I'm going to use this to mix with some other beans that I roasted just prior. The other beans were Colombian and 90% Colombian, the other ones were, and 10% Java Robusta. And I felt that after I was trying to make my espresso blend, and I felt that after I did it, it needed more brightness, needed more Central America notes. So I have some Nicaragua Cafe Diego in here, some Honduras, some Dominican Republic, and also some Mexican high ground, and all at equal ratios. And then I put another little scoop of Java Robusta, and that's just for crema formation at the end. So I'm going to be filling up this center chamber right now with it, and I'll bring this over. To do that, kind of show you how I do it. I just get my scoop and I just put them right in there. I try not to get it in that center. I cut this out right for a second and give the battery a little more charge. I'll see you in just a tiny bit. I'm going to finish filling this up. Okay, I filled up the bean container with the beans. You can see that. Now all I do is I get the top lid, as such. I just put it right on. Trying just to assure that it's going to seal all around. Just making sure of that. Everything looks fine. Usually not too much of a process. There we go, just kind of look around. Alright, now it's going to show you a little example of the, I'm going to set the PID, and also you'll be able to see the igniters work. The gas is turned off at this point still. This is propane. I take this cylinder outside when I'm done. Probably not supposed to have it inside, but for this brief period of time, and I know there's no leaks. It's cool. Alright. So it turns the PID now is, you can see it say 61, 62. That's what the temperature is inside the room here. So I want to set it to 454 ultimately. Okay, the first step is 61 degrees ambient temperature for 3 minutes. It goes, in the next 3 minutes I have it go up to 300, which is a drying phase. Then in 4 more minutes I have the profile go up to 385 degrees, and then 5 minutes to the very end, which is, I got it set to 454, so I had it previously set for a city roast. 454 would indicate a full city cost roast. Set that. Negative 21 on the timer on a timer phase indicates a shut off of the whole profile. Let's make sure I got that all correct. Again, right, 61, 3, 300, 4, 385, 5 minutes to 454, and then off. Okay. Turn that off. That just turns it okay. You can hear the fans. That's just the interior fans here. Do a little test of the vacuum. There you can see the spout. That's fine. I'm going to turn the heaters on so you can see what they look like. You see them glow red hot right now. They stay on throughout the whole roasting process. What I'm going to do is I'm going to put these little guards over on each one. I've got 2 burners here. Go down, and I'm going to turn the gas on. And I should have it set good. And get that fluid bed going. Briefly, I'm going to start the process. Up right now. typical. Much to see. It's hot. Catch up here. That's a pretty quick drying phase up to 300. Now to 385. This is when it really starts catching up. You can already see some of the chaff start coming off the beans. Spot right there on in the roasting, in the flame burner. What's nice about this negative air pressure design, it makes for a compact unit. I mean, we are roasting 2 pounds of coffee beans here, and it does have a fairly small footprint for 2 pounds. Another benefit is that you don't really have to worry about air leaks, because you're not going to get smoke coming out of the air leaks because of the negative pressure. It's like a pellet stove. Pellet stoves work on negative air pressure. You can see we only have about a 20-degree differential now in temperature. Now only 14-degree temperature differential. Once the 2 numbers meet, the gas will turn off. turned off. You can see that turned off now. On pretty soon again. There, kicked on again. Probably hear a little clicking noise in the background. That's the solenoid valve kicking on again. At this point forward, it holds the profile pretty well. Just the beginning where it lags a little bit, but that's to be expected. All in all, I think it's more responsive than the electrical 220 volt heaters I had. See, the beams have expanded quite a bit. Right now we're on the last leg. It's past 385, so we're 5 minutes after 385 to get up to 454. Just turned on again. At this point, we'd already be going into a City Plus roast. 436 on top before a full City Plus. Excuse me, a City Plus. 444 will be a full City. 454 full City Plus, and that's what I'm going for. My initial batch of the Colombian Peaberry and a little bit of the Java Robusta. I did that at a city roast, which is 426 degrees. Well, I want to do this little experiment here, add a little roast character to it, a little caramelization of the sugars that you'll see in a full City Plus. I think both of them together will be nice. nice about this clear glass top, you can see the color of the beans, perfect. Real nice. It will likely get to the top now. 400 and, yeah, it will. At this point I start squirting that water in. Try to catch that as quickly as I can here. You can see the water go in. See a squirt on the top. I got it pretty close. Now 456 to stop totally. That's pretty cheap. I consider that a pretty decent achievement for a little homemade roaster like this. Be able to stop it pretty fast. You can see it's going down pretty fast now because of my water misting. Turned off the igniters, of course. As you can see, it says stop. It means the profile is done. Won't be calling for any gas at all now. One last squirt, and then I call it. That's it. See what started out in the chamber as about half, maybe a little more than half full. That chamber inside there is full, but it still has the fluid action, and the beans look beautiful, absolutely beautiful. See how they're staying right in the center chamber because of the lid and the suction. At 199 degrees Fahrenheit now. Stop the camera for a second because it needs energy. Alright, as you can see, I gave it down to 86 degrees. It was only a couple minutes. I didn't charge the camcorder before I did this, and I should have. That's why I had to stop and put it in there. But when it gets to 80, I'm going to stop it. But look at this. See the activity there? A lot of freaking rotation of beans going on there. They're all getting equal treatment, I guess to say. Alright, we hit 81 degrees. Turn the fluid bed off. turn the roaster off. I'll take the cover off now to show you the beans. And there they are. There's the beans, all nice and roasted. You can see over here in the corner, maybe. See if I get it in there correctly. Whoops, here we go. See all that? That's all the chaff that got. That's all chaff. Right in front of my de-chaffer screen. Chaff collection screen. And separated it all from the beans. And that's it. Now I just get the beans out using a special tool I made. It's like attaches to my vacuum, and it just sucks the beans right out of there into a container. And then I'm going to just mix these with my other beans to make a blend for my espresso machine. And that's it. If anybody have any questions at all about this, just ask. I'll do the best I can to help. Thanks. Bye.